Well, now let's evaluate compositions of trigonometric functions. So a composition of a function is the function of a function, or the function within a function. And if we look at this one on the left, we have one function here, which is the inverse cosine. And the second function that we have here is the sine at pi over 3. Composition of a function within a function. The function of a function. All right, so to evaluate this, we first got to think about this function here, the sine of pi over 3. So what is the sine at the general angle pi over 3? And you might recall that that is the square root of 3 over 2. And so now we're thinking about, okay, well, what is the inverse cosine, now that we've solved that? What is the angle when the cosine is square root of 3 over 2? Now let's think back on that unit circle. Where is the cosine equal to square root of 3 over 2? What's the angle measure at that point? And you may recall it's at pi over 6. And so that's our answer. That's the inverse cosine of the sine at pi over 3. Now, here's another one. We got the sine of the arctangent, or the inverse tangent, 5 over 12. Now, this is not going to be an angle. We're not going to end up there. So we've got to find the arctangent. What is the angle there at that point? Then what's the sine of that? Well, it's not going to be one of those general angles, so I think I'm going to sketch a 90-degree triangle. Maybe this will help me. Now, I might remember that the tangent itself is, and let's say this is theta here, is the opposite over the adjacent. Also, the tangent, and I guess my first have started here, is the sine over the cosine. But also, on the coordinate plane, the tangent is y over x. All right, so I got this right triangle, and if I think about this as the opposite over the adjacent to this theta, then that means that this measure is 5, and this adjacent side is 12, and what I don't know is that hypotenuse. Now, what's the sine? Well, the sine, we may remember, is the opposite over the hypotenuse. So I need to find, if I find the hypotenuse, then I already know the opposite side. I just need to know the hypotenuse to come up with the sine of the inverse tangent of 5 over 12. Well, let's do that. So I'm going to use Pythagorean theorem. So I got 5 squared plus 12 squared equals, we're going to say c squared. We'll just label this as c for the hypotenuse. 5 squared is 25. 12 squared is 144 equals c squared. And 25 and 144 is 169 equals c squared. And we're going to take the square root of both sides so that the hypotenuse, or c, is equal to 13, because the square root of 169 is 13. So now that's 13. We found it. And so what's the sine then? The sine is going to be 5 opposite over the hypotenuse, 5 over 13, based upon the inverse tangent being 5 at 5 over 12. Compositions of trigonometric functions. Cool.